Hello everyone and welcome back to the channel. In the previous video, we saw how to simulate half-wave rectifier. In this video, we are going to simulate a full-wave bridge rectifier using Ngspice. A full-wave bridge rectifier is a circuit that converts AC input voltage into a DC output voltage by using the 4 diodes arranged in the bridge configuration, as you can see here in the circuit diagram. Unlike the half-wave rectifier, which uses only one half of the AC signal, the full-wave bridge rectifier makes use of both the halves, resulting in smoother DC signal. So this is the input and output waveforms. This is the input waveform here, which is sinusoidal wave, and this is the output waveform which will be available at the load resistance R. So during positive half cycle, let's say on top it is positive, bottom it is negative. So when this node is positive, D4 will be reverse bias, and when this node is negative, D3 will be reverse bias. So two diodes which will be conducting is D1 and D2. So current will flow from the supply D1, load resistance D2 and back to the supply. So you can see here during positive half cycle there will be current flowing through the load resistance. So during negative half cycle, let's say it is negative on top and positive at the bottom. So positive over here will make D2 reverse bias and negative over here will make D1 reverse bias. So the two diodes which will be conducting is D4 and D3. So now the supply will flow from D3, load resistance D4 and back to the supply. So you can see during the negative half cycle there will be the current flowing through the load resistance. Now we'll make a Ngspice code and try to simulate this waveform at the output. So let's write the Ngspice code. So this is the circuit diagram. We have here 4 diodes D1, D2, D3, D4 connected in bridge fashion. This is the load resistance R1 which is 16.6 kilo ohms, and this is the input voltage V1 which is 10 volts 50 Hz. I have marked the nodes here 0, 1, 2 and 3. So first line will be the title line. So let's give the title full wave rectifier. Next let's define V1 which is connected between node 1 and 2, and I am giving the sinusoidal wave with the voltage 10 volts and the frequency 50 Hz. Next let's define the diodes D1 which is connected between 0 and 1, and diode model name I'll give as diode. Defining the second diode D2 which is connected between 1 and 3, and model name let's give same as diode. Defining the third diode D3 which is connected between 0 and 2, and model name diode. And the last diode D4 which is connected between node 2 and 3, and model name as diode. So we have defined all 4 diodes. Let's moving on to the load resistance R1 which is connected between 0 and 3, and the value of the diode is 16.6 kilo ohms. Now let's define the model of the diode. So dot model, name of the model I have given previously here as diode, and type of the model is diode D. Defining the transient analysis dot trans, the time will go from 0 to 50 milliseconds in the steps of 0.1 millisecond. Next, starting with the control, Run. Now here we need to plot input and output. So we are plotting input, which is between node 1 and 2. So this will give the input sinusoidal wave, and output will be available at a load resistance R1. So we can give V at the output node 3. Next, ending the control section, end C and dot end. Now let's copy this in the text document and try to simulate this. So let's save this file. Full wave rectifier .sp. Let's open the console and run the file. So you can see the output and input waveforms. The green one is the input waveform and red is the output. Now here you cannot make out both the waveform as it is overlapped. So I'll just separate these waveforms. So I'll take the output waveform on top of the input. So let's say I'll make some changes in the code. So I want this red waveform starting from the 10 or 11. Let's add here 11. Save this and run again in the console. Now you can see this is my input waveform, which is in green, and red is my output waveform. So that's it for today. If you found this video helpful, then don't forget to like, share and subscribe. Also, if you have any questions or suggestions for future videos, then let me know in the comment section. Thank you for watching.